point charges Q1 is equal to positive 2 microcoulombs, which is times 10 raised to negative 6, and Q2 is negative 2 microcoulombs. We have a given length of 3 cm, and as you can see here, we have a diagram that is square. Now, what's the electric potential at point A due to Q1 and Q2, and what's the electric potential at point B? And let us see. A point charge Q3 is moved from point A to point B. Now, as you can see, we're still knowing the R, and R is equal to C, which is C is equal to square root of A squared plus B squared. After which, let's write down things here, such as the conversion. So 2.12 cm is equal to 0.012 m. Now, I will be correcting myself here because point B is apparently the other side, because it must be the empty corner closest to Q2. So you will see it later on. We are calculating for VA due to Q1 and Q2. So we have VQ1 and VQ2, which is calculated as 848. And then summation of that would be 848 plus negative 848. And VA is 0 volt. For VB, same approach. You have VQ1 and VQ2 as well. But this time, we'll have your new radius or new distance. So instead of using our 0.012 m, we know that your radius right now will be something different. And again, B is located closest to Q2. Your radius would be from Q1 to B. That would be 3 square root of 2 or 4.24. In this case, it's cm. But if it's Q2 to B, that is only one side, which is 3 cm. Now, applying the formulae, we have KQ1 over R1 and KQ2 over R2, both for our Q1 and Q2. But this time, referring or focusing on our point B. Summation of this, VB, would just be equal to VQ1B plus VQ2B. Unlike our VA, we have negative 194. And lastly, we need to know how much work is done on Q3 by electric forces exerted by Q1 and our Q2. Remember that we have Q3 charge from point A, or from the center, to point B. Our work is given as Q times the change in potential, or electric potential. Now we have another problem here, 2-point charges Q1 and Q2. This time they are 0.1 amp apart. Point A is midway between them. Excuse me for that photo because I use Zoom. Point B, between them, point B is 0.08 amp from Q1 and 0.06 amp from Q2. And here I'm trying to have a figure drawn. Alright, for the first one, letter A, it says here, find the potential of point A. Here, I'm trying to have all the radius, all the radii listed. For RA1, A to Q1, that's 0.05, A to Q2, that's also 0.05 amp. For VA, same approach, KQ1 divided by R1 plus KQ2 divided by R2. Why do we have Q1 and Q2? Because we have two charges that could affect our point A. After the calculation, we have negative 7 37.22 volts. And for point B, same approach, listing all the red eye from point B to Q1, from point B to Q2. VB is equal to KQ1 divided by R1 plus KQ2 divided by R2. Plugging in all the values, we will get negative 704.73 voltage. And to know the work done by the electric field in a charge 2.5 nano, same thing, which is W is equal to charge times your voltage. Now the charge here is given as 2.5 times 10 raised to negative 9. And by the way, instead of negative 6, those are negative 9. Sorry. And the voltage here is VA and VB. So that's going to be VA minus VB.